Was it in there? So what happens here is yesterday, the order mattered. It mattered yesterday when we're dealing with what were called permutations. There was a specific place for people to go. When you were picking your batting order, you had first person can go there, second person can go there, and so on. But what happens now with what are called combinations, combinations are when the order doesn't matter when you're selecting something. Combinations the order doesn't matter. So Clay's question of, well, let's say there's 8 class periods and you have 7 classes. So if there are 8 periods in the day, then you have 7 classes. Because one of the classes is going to be, well, like you were saying, is a study hall. And the order in which those classes are placed, it doesn't matter where they're put on your schedule. Okay? In reality, it does kind of matter because with Kish and other things, we do have to stagger classes at certain times. But that's a whole other scenario. In the generic sense, since you have 8 periods and you're choosing 7 of them, what are all the options you have of mixing them up? Well, this is where N choose R comes from. This is when the order doesn't matter. You saw that button on your calculator. It was right below the NPR one. Yeah. Now, these are your number of choices. This is how many you're picking. So you would wind up with what it would be 8, choose R, choose 7, and mathematically, this would be 8 factorial over the quantity 8 minus 7 factorial times 7 factorial. N choose R, the generic formula for that is N choose R. I know we talked about permutation yesterday. It would be N factorial over N minus R factorial R factorial. These types of problems lead into very easy fractional simplification. Very easy. Because what's 8 minus 7? 1. What's 1 factorial? 1. Now, if I'm starting to think about 8 factorial, if I write it all out, where do I stop? 8. And why do I stop at 8? Because 7 is the denominator. So 8, choose 7. How many options do you have? 8.
Order doesn't matter. There's only 8 ways to start.
Here's why. Again, here's the reason why this works. 8 factorial is 8, 7, 6, 5.
3. No, Jenna. There's only 7 number 8.
That's 8 factorial. 1 factorial is? That was tough. And 7 factorial is?
3, 2, 1.
What simplifies?
7.
The entire right side.
And that's why you get 8. Okay? It's not like Satan showing up.
Oh my god, I still think I'm really funny for that.
It is pretty funny. 1 factorial is 1, because it's just 1. Right? Now, Clay, the other thing is that the combination, we don't write all this out. We might have hinted at it yesterday, where we said a combination lock should be called a permutation lock, because the order in which you put the 3 numbers in is specific. You know, 13, 27, 12. You can't go 27, 12, 13. You won't get into your locker, you won't get your lunch, and you'll be hungry.
They should make locks like that.
Okay. So wouldn't that just take away possibilities? It would be. It would be a lot easier because the order in which you tap the lock wouldn't matter.
You know,
It would also be hard
what
to
if you
forget
forget the
though.
order of your combo? So
So combinations,
It's 6.
the order in which you select things, it doesn't matter. And a really easy way that I like to show these things is going to be with cards. I like showing combinations and how these things work out with cards because it's visual and it's, most people know what's in a deck of cards I hold.
54 cards.
50. No, we don't count the jokers. And I'll go over with you guys, for those of you that have forgotten how to use a deck of cards, I'll go over that with you.
Don't give Justin, throw the cards in the
It's a good my dad. You just throw cards.
Yes.
My dad, they card pickup. Because he said you should.
So, when you're dealing with the deck, and that's that form we just used, Clay. That's the exact same thing we just used.
Okay, thank you.
If you're dealing with a deck of cards, there are a few expectations that I'm going to have for you guys for generic knowledge. I'm not going to ask you know how to play poker. I'm not going to ask you know how to play blackjack.
I play go fish.
All right. I might ask you to play 52 card pickup if you want to do that.
Don't be like it, I can play war and I'm really good at it.
I should get water.
It's all about the luck, and I'm really
It's dumb
lucky.
luck.
All right, here's Clay's card.
Yes! Let's see, who am I playing war against?
Me. Are you kidding me?
You lose.
Seriously?
Good no one
I'm done. Good night, everybody.
Clay's a wizard.
I told you what?
Let's try it again. Try it again. That's 2 out of 3.
Seriously?
That's 2 out of 3. Come on.
That was perfect.
They don't know which cards there were.
No.
So anyone who wanted that
Well,
doesn't
they
know.
know he lost. They know that Mr. Murphy got.
No, I didn't. I won. But you lose because I'm bigger than you. So the deck of cards.
Mr. Murphy's a sore loser.
Yeah, I'm going home.
I don't play him.
Yeah. So in a deck of cards, just generic knowledge in case you have forgotten these things. You have 52 cards. There are 4 suits. We have diamonds,
Yes,
She's in the sky with them.
yes,
hearts,
that's also.
Shut up, John.
So bad job.
a spade.
That one is good.
All right, we have a spade.
Oh, yes.
I must have said what with a
And a club. So obviously I'm not a tattoo artist and or a drawer. My children draw better than that, but that's besides the point. I want you to recognize that there are, half the deck is red, the other half is black, suits 26 and 26. Of the 4 suits, there are how many cards in each? There's 13 in each. We have the numbers 2 through 10, Jack, Queen, and King, and the Ace. I think this book goes by face cards just being your Jack, Queen, King, depending on, sometimes people call an ace that, but just remove a face on an ace.
You're wrong. You're right.
Oh, I just didn't know
At this point, you do know I purposefully said that line.
it. So mad I lost to it.
I thought you were going to say a 3-year-old.
He's not.
I'm a winner! Shut up. So what I want to think about is when you're looking at possible cards hands, it was not as much fun as actually doing it. What I want to look at is how many of these, before I do this one here, sorry, let me back up. How many possible 5-card hands are there? I want to think about how many possible 5-card hands are there. It's actually mind if I move your stuff down here? I need space, and I'm going to play some 3-card Monty with you. Keep an eye on the card. Let your money down. You don't know what I'm talking about, do you?
No, I do.
So you had smiley faces written on 2 cards.
Mr. Murphy, is it 52 times 51 times 50 times 49 times 40?
No, that's ways of arranging.
No, magic Matt. My mom calls her magic.
Now, what I'm thinking about here is when you're playing poker, standard 5-card poker, you
It's
get
fun.
5 cards.
It's really fun.
Guys, let's put Mad Angel with it, Magic Matt.
So one of the hands that I just drew out was 7-3, King, 5, King. That's one of the possible hands you can get.
Yep.
Now, how many possible 5-card hands would there be out of a deck of 52? Well, a lot. Yes, the answer is quite a bit.
52 times 5?
Correct, because what you're looking at, does the order matter in which I deal out the 5 cards? I'm picking 5 of them out here. I can pick this one, this one. And if you're picking from the bottom of the deck and you're, playing in Vegas, you can probably get a very shallow grave in the desert, but it's not wise to do that. So when you're looking at this, if I want to pick that out, there are 52 cards in a deck. You want to pick out or choose 5 of them. Now, I want to show you again how extremely simple it is to write this out in long form. You get 52 factorial over, 52 minus 5.
47.
You guys okay with just writing it as 47 factorial? And 5 factorial. If I go to write that out long form, what's my numerator going to be? 52 to what?
No. Oh, 52.
Good. All I have to write it out is to 52 to 48. So 52, 51, 50, 49, and 48. Why do I have to, why can I stop? 47 simplifies everything else out, divides it out. The denominator then gives you 5, 4, 3, 2, 1. So let's simplify this. Does the 1 have any bearing on it?
No.
All right, so leave them alone. What's 5 times 2?
10.
10. 10 goes into 50 how many times?
5.
So what I'm going to do is simplify out 5 to 50, rewrite that as a 5. What's 4 times 3? 12 goes into 48 how many times?
4.
So the 4 and 3 go away, and this becomes a 4. So my numerator now, in simplified form, without having to use a calculator, becomes 52, 51, 49, 20. That's something I would expect that you'd be able to do. You could leave it like that, because if I don't give you a calculator, that's a legitimate answer.
Alright,
Fair enough?
Yeah. That's pretty good. We have maybe like 20 times 52.
No, I'd say you're okay there. It's not that bad. Now, what do you get when you multiply that out?
2,598,960.
2,598,960. So what you're telling me is that there are 2,598,960 possible 5-card hands. I forgot what I was doing. Combinations of 5 cards. So we have 1, 2, 3, 4, 5. Here's your 5.
It's really not that easy to get up.
Yes. What do you got? It doesn't matter. You have ace high with the jack. What do you have? Ace high with the jack. Ooh, who wins between ace high and the jack? What's your next highest card?
7-9.
Oh, you win! But I beat you because I have ace high with the king. So I win!
It's still higher than a 2.
I'm not playing
gonna let you
against
win, though.
play.
It's still higher than 2.
Wait, plan one.
Do it again.
Maybe later.
No, right now.
Oh,
We're all gonna forget.
that was bad and you should feel bad.
Yeah, I was never really good at shuffling. Whenever I played cards,
Job? No, this is like your job. Is that
people would get annoyed with me with my shuffling just to get cards. So I never played.
Oh, you mean
All right. So let's take this a step further then. In how many of those hands, that 2 million something, how many of those would be all 5 cards of the same suit? How many of these hands would have all 5 cards of the same suit? Do you know what that's called in poker, having all 5 the same?
Flush.
Flush.
Is that bad?
If they open a road to
No, a flush is really good.
Oh.
the royal flush is better.
Royal flush is better, a straight
Full
flush
house
is
is better.
still pretty good. I think the only thing that beats a flush is a straight flush, and then which the royal flush is a straight flush, it's just pretty good. It's just royal, I guess that's a crown. Now, what I want to think about here is, it's talking about, you've already have the 2 million some odd cards to play with. You want to get all 5 of them to be the same suit. Well, how many suits are there? 4 of them. So how many do you have to choose from? How many do you want to choose? 1. You're going to take the 4 suits, you're going to pick one of them. You're going to choose 1 suit. So what happens is, the first card that comes over is your suit. It's hearts. Because I'm a loving person. I'm not going to get one of the combinations. I didn't get it. So there's one of them. So now let's see if I'm a club. It's like Club Baby Seals. Yeah, it is.
It's like Club Baby Seal.
Just you tone out.
This is the fun part of the school year. We get to do like cards and probability and stuff. This gets to be fun.
Probability
Now,
two,
after that I picked out the 5 cards of the same.
Yeah.
Mr. Murphy.
Learn
Can we figure out
magic.
the probability of learning a 2 after a 3?
Can we please? I don't know. It's really
There is a way of doing that, and yes, eventually we will. I'm sure Clay will remind us when we start looking at independent and dependent events.
You'll never live this down. Never.
Except next year.
Thank goodness I don't have to deal with you next year.
Well,
What happens if what if I just tank my grades so I can take this class next year?
Do it.
Now, what I want you to think about here is you've chosen a suit. Okay, we've chosen a suit. How many cards within that suit you have to get? 5 of them. So your next thing here was 13, choose 5. And what we do is we multiply those 2 together. The reason that we need to multiply those 2 together is because they are dependent upon one another. You want the same suit and all 5 cards the same. There's going to be a difference here in a little bit about when we add or when we multiply. It is very distinguishable. It is so simple to see the difference in what you're doing. Okay. If you want to pick, before choose 1, this is where you're just going to use your calculator. It's pretty quick. You put it in there just exactly the way it looks, hit enter, and what do you get?
5,000 something?
5,148. So what that means is that there are 5,148 possible combinations of 5 cards being the same suit. There's 2 away. All right? But the probability of getting that is very far-fetched. 5,148, that's a lot. I wouldn't mind that many dollars. Good. But I'm out of 2 million something. So how do you figure out, this isn't really in this section yet, but I just want you guys to see the idea here. How do you find probabilities?
Percentage,
It's like percentage, right?
it's the
Yeah.
ratio.
It's ratio, favorable divided by total outcome. Well, this was my favorable, what I have here. The favorable amount is 5,148. The total possible outcomes of dealing a deck of cards, five draw, was 2,000,000,
Use the same concept to find out what I was asking earlier, right?
kind of. The answer is not gonna happen. 0.19% probability of being dealt a flush.
What if I were to just do
If
it
you
like
get
that?
a flush and you're dealt a flush, bet everything.
Well, then people won't join the game, and we'll just, like, just
And you have a good poker face,
Yeah.
Angel, that's the whole term.
That's the whole term.
But if it's not a Friday, you might not be there.
Oh.
It's
I
hilarious.
won't be there till later.
I won't be there either.
You know, that's what they used to do. They would wager livestock in the West.
Oh, like in Jack and the Beanstalk?
We didn't wager that. Either gambling in Jack and the Beanstalk or was just Jack just gonna crush him because he was bigger. Like I could crush Clay.
That wasn't gambling.
That wasn't gambling. That's trading. There's a slight difference. Not much, but slight. It's like this. Val, that's your card.
Okay.
I don't know what it is, but this is my card. Do you want to wager your card versus my card?
If you were
Yes,
if you were as
yes.
lucky as me, you would have already
That's-
won.
Nobody likes you. So that's gambling.
Wait,
What'd you get?
I don't know.
Well,
I'm not encouraging gambling. I was showing you an example of what gambling is.
I'm scared of losing again.
You're gonna get your mouth. So this was your card, right?
Yes.
And this should be a reason why when you guys turn 18, you don't gamble.
Whoa, winning.
You gamble against you.
Going to school.
We'll gamble against
Because now we have
us.
valid count.
Across the street.
Oh, you're right. I should. Remember how they got loosed in the other thing?
You can trade it for.
Oh, that's right. I have a picture of it up close. You know, when
His name is Grandpa Grizz because he has a grandpa face.
Okay, remind me, I will show you the picture. It went pretty funny. Just driving this go, ow.
How we trade
Now-
beans.
When we're dealing with combinations, there are compounding events that can occur. You have the idea of being able to multiply or add. The last example we just did is that we want to have all the same seeds and then the 5 cards. So that's why we multiply them together. I have a very easy example to show the difference between multiplying and adding. The language within the problem is very subtle, but if you pick up on it, it's really easy to distinguish when you do what. Let me show you. A restaurant serves omelets that can be ordered with any of the ingredients shown. Part A. Suppose you want exactly 2 vegetarian ingredients and 1 meat ingredient in your omelet. How many, it's italicized, yes, good observation. How many possible ways can you pick your omelet? Now, notice you're picking 2 vegetables and 1 meat. They're inclusive of one another because you want to have all 3 of them at the same time. You're trying to find the combination of having 2 of the vegetables as well as one of the meat. Whereas the second one, yeah,
Why are they called vegetarian if like you can get meat with them? Like why don't you just
your
call them
vegetarian
vegetables?
options.
Okay.
In case you didn't know that a green pepper is a vegetable.
Yeah. Like cheese, what's that? It's not vegetables.
And
It's
the,
not vegan, it says vegetarian, not vegetarian.
if I'm looking at part B, look at how it's written here.
That's a cheap omelet.
I guess so. Suppose you can afford at most 3 ingredients. Does it say anything about having to have so many of one and so many of another?
No.
But it also says the word at most. When you see at most or at least, that's a lot of time when you're adding. When it's saying exactly or when it's going to occur, that's when you're going to be multiplying. So what happens here in part A If you want to get exactly 2 vegetarian and 1 meat ingredient, how many vegetarian ingredients do you have to choose from?
6.
And how many do you choose?
2.
So it becomes 6, choose 2. And I'm going to multiply that by, because I want it to occur as well,
4C1.
4C1. That'll give me my total combinations that I can get of 2 veggies and a meat ingredient in my omelet. That makes sense? What do you get, Tom? Did you check it out? I thought you were 60. Okay, not bad. So there are 60 combinations of getting that. All right. Never had steak and eggs? Well, it's kind of like that. They're just mixed together. Okay. Suppose you can afford at most 3 ingredients. It's not specifying vegetable or meat. It's just saying ingredients. How many of them were there? 10. There's 10 total ingredients here. Now, if you're picking an omelet, you can get at most 3. So what's the most you're going to pick? 3. So you're going to have 10, choose 3. Could you pick 2? Or you can have 10, choose 2.
Or 10, choose 1.
Or 10, choose 1. Or none. I could just get eggs.
Well, then that ruins the fun.
Plus,
Then why are you spending that much money on an omelet?
maybe maybe 3 eggs. An omelet with nothing in it is cheaper than getting 3 eggs.
I don't think so.
Wait,
There's a lot to put together.
I mean, that's $3.
I can just put them together.
$3?
It doesn't matter. It
$3 for an egg.
doesn't say how many eggs. It could be 6.
Oh, well, that's crazy.
That'd be a lot of omelet.
Yeah.
So what do you get from this one, Tom? 176. There's 176 things you could do by just picking any 3. You could pick any 2, pick any 1, or just none.
It's $528.
Kind of.
That's a lot of dollars for an omelet.
It is a lot of dollars for an omelet. Oh, wait.
Does that make sense in how that looks?
Yes.
The other stuff that's in this unit is what we call binomial expansion. It does, because we did a little bit of it before. Binomial expansion is when you guys like to, murder and slaughter puppies.
Why do you keep checking the card like every 30 seconds?
I'll give you that one. Now, remember, we've done binomial expansion. You guys would say, oh, that's just going to be 2 to the 7th, x to the 7th, 3 to the 7th. And you murdered and slaughtered puppies. Whereas I told you had to FOIL all that out 7 times and you got mad at me. Well, believe it or not, there's an easier way. I'll show you that tomorrow.
Now you have
I just need to space in my paper for this. And they're like, yeah, I'll show it to you tomorrow. Never mind. What?
Wait, so if you were to go to the omelet place, it would cost $758 just to get all types of omelets.
That's too much omelet.
It's too much.
Say hello, Mr. Cholesterol.
I never heard of it. I know it can be high. It's about like the P and the C.
The key doesn't, the order matters as you're going through things. So if you're picking president, vice president, treasurer, if you're president, you're not treasurer.
Yeah, I did like it.
If you're just combining everybody to see who can go to which places. That's
I
all.
like Chipotle.
I hate people say Chipotle.
You mean Kelly?
That really gets me.
I think it's 51 to skip, right? Okay. Yes. So I want you to try those out tonight. And we'll get into that whole binomial expansion theorem tomorrow. It has to deal with Pascal's triangle. You had Sev last year. I think you guys saw that. Pascal's triangle is how binomial expansion works. Sorry, I wanted to go on that one, man. I'm sorry.
only test waiting. I did it on the bus ride. I did it on the
No.